Let's talk about basics of logic. Today we will discuss about rules of inference and rules of replacement. Let's recap what we have said last time. Two statements are logically equivalent if they always have the same truth value, meaning that they are true under the same conditions and false under the same conditions. If statement A is logically equivalent to statement B, we write A is equivalent to B. A statement is called a tautology when it is always true in any case. For example, PLP is a tautology since it is always true no matter what the truth value of P is in the table below. A statement is called a contradiction when it is always false in any case. For example, P and not P is a contradiction since it is always false no matter what the truth value of P is in the table below. So you can see no matter P is true or false, P and not P is always false. Both are F here. A statement is called a contingent statement when it is neither a tautology or a contradiction. In other words, a contingent statement is sometimes true and sometimes false. For example, PLQ is a contingent statement as both T and F appear in the column of PLQ in the table below. So you can see both T and F appear at the last column. Let's talk about rules of inference. Rules of inference are ways of deriving conclusions from premises. They are all tautologies. I will list some of them. The first one is the simplest one, called Modus Ponens, abbreviated as MP. So it means that when P implies Q and you know that P is true, then you can deduce that Q is true. This is very easy to understand. So using a truth table, you can prove this statement is a tautology. As in any cases, no matter the truth value of P and Q, they both have the truth value of T here. Now let's talk about disjunctive syllogism, abbreviated as DS. So if you know that P or Q is true and you know that one of them is false, then you can deduce that another statement is true. So in this case, P is false, so you know that Q is true. Let's talk about Modus Tollens, abbreviated as MT. If you know that P implies Q and Q is false, you can deduce that P is false. Let's talk about hypothetical syllogism, abbreviated as HS. So you know that if P implies Q and Q implies R, you know that P implies R. You can show that this rule is valid using truth table, and the details are omitted. So for simplification rule, it is easy to understand. If P and Q are both true, you can drop one of them out and leave one. So P is true and Q is true. For addition rule, if P is true, you can add a statement Q no matter Q is true or false to make it a disjunction of PQ. Repetition. If P is true, then P is true. It's valid, and the truth table of it has been shown in the third slide. Constructive dilemmas, abbreviated as CD. This one is a bit difficult to understand, and this rule can be proved by natural deduction. But I haven't talked about what a natural deduction is, so I may leave the proof to the videos later. So for this rule, if you know that P implies Q and R implies S, and you know that P or R is true, then you can have a conclusion that Q or S is true. So now let's talk about rules of replacement. Rules of replacement are used to substitute one statement form with another logically equivalent one, preserving the truth value of the overall expression. I will list some of them. The first one is double negation. So the negation of P is the equivalent to P, as shown in the truth table here, because they have the same sequence TF and TF, so they are logically equivalent. Now let's talk about De Morgan's laws. When the conjunction of PQ is false, then you will know that at least one of them is false. So we can show it here. If the disjunction of PQ is false, then you know that both of the statements are false. This rule can be shown very similarly using a truth table, just like the previous slide. Then this is called the distributive laws for conjunction and disjunction. This is called the transposition. P arrow Q is logically equivalent to not Q arrow not P. And this statement is called the contrapositive statement of P arrow Q, as discussed in the previous video. Now here comes the material implication. P arrow Q is equivalent to not P or Q. This is already explained in the previous video. If you haven't watched it, it doesn't matter. So you can just construct a truth table to prove this fact. Let's talk about material equivalence. Material equivalence is a statement that P double arrow Q is equivalent to conjunction of P arrow Q and Q arrow P. You can show the truth table here. So you can notice that they have the same sequence TFFT and TFFT. So they are logically equivalent. This is the end of my video. Thank you for watching. If you find my video interesting, please consider subscribing to my channel, like the video, and comment down below. See you in the next video.